All right. Hi, everybody. Welcome back to section 7.2. And in this video, we're going to define a Laplace transform of a derivative and higher order derivatives. Okay, so previously stated, our main goal and the main goal of this class is to solve differential equations. And the goal for this section and chapter is to use Laplace transform to solve these differential equations. And in this case, the differential equation are initial value problems. Okay, so if that's the case, because they could look like, AY double prime plus BY prime plus Y equals 0. We have some initial conditions like Y of 0 equals Y naught. Y prime of 0 equals, Y1, things like that. Uh, so that's our goal to solve some initial value problems. So we need to be able to evaluate some Laplace of derivatives like Y prime, Y double prime. Okay, so here's the definition of derivative of a Laplace. So, let F prime, F double prime all the way up to F to the n minus 1 derivative are continuous on the interval 0 to infinity, are of exponential order, and the nth derivative of t is piecewise continuous on the same interval 0 to infinity. Then the Laplace transform of the, here I'll say like nth order derivative is this setup right here, s to the n times f of s minus s to the n minus 1 times f of 0 minus s to the n minus 2 times f prime of 0 minus all the way down to f to the n minus 1 times 0, where f of s is a Laplace transform of f of t. Okay, so this is in the case where it's the nth derivative. Okay, but we're not really going to deal too much with that highest order of derivative. What we're primarily going to be focusing on are the ones more common to us, like y, y prime, y double prime, perhaps y triple prime. We're just going to focus on the second derivative as of now. But just so you know, these are what the Laplace of these derivatives are. And it all derives from this formula and definition. Okay, so it says y. Just don't get that confused with, the definitions. Y is the same thing as like f of t. Okay, so don't get that mixed up. It's the same thing as like, y of 0 just means f of 0. Okay, they mean the same thing. So that's why if you have like, y prime, you end up with f of 0. It's the same thing as like y of 0. So what I want to do is at least prove one of these to you. We don't have to go through all of them. I just want to show why, one of these derivatives, the Laplace of it, actually is true. So I want to do the Laplace of, let's look at y prime. Okay, so y prime, I want to find the Laplace of this derivative of y. So what's the definition of a Laplace transform? So remember, it's 0 to infinity, e to the negative st, and then it's times y prime. Okay, so maybe I could write that down like definition, you know, Laplace transform of a function is 0 to infinity, e to the negative st times the function. Okay, so we want to integrate this um, setup. So we have an exponential, we have a y prime, but that's also two unrelated functions. And so in that case, we would need integration by parts. Okay, so here you would be e to the negative st. dv would be that y prime dt. And so the reason I'm setting that up is because if I take the antiderivative or integral of y prime, what I end up with is just y. And so the derivative of e to the negative st is negative s e to the negative st dt. Okay, and integration by parts is, uv minus the integral of v du. So we are just crossing over. So my integral becomes e to the negative st times just y, and we're going from 0 to infinity, minus the integral of 0 to infinity, y times negative s e to the negative st dt. Okay, so what could we do here? So let's drop some of these parentheses. Let's clean this up a bit. So this would be y. I'm going to bring that exponent down, e to the st, going from 0 to infinity. And I'm going to take out this negative s. And so this would be plus s times the integral of 0 to infinity, y e to the negative st dt. Okay, and so one other thing I want to do as well is kind of change y, because remember, y is the same thing as f of t. I think I want to change y to be f of t so that it could be a little clear what is going on. So I'm going to write, you know, y equals f of t. Okay, so this would be f of t over e to the st over 0 to infinity plus s times the integral of 0 to infinity f of t e to the negative st dt. Okay, so the reason I did that is because what is the integral of 0 to infinity f of t times e to the negative st dt? What is that? Well, what that essentially is the Laplace of f of t. That's exactly what we have right here. And so this whole integral becomes, or is the same thing as the Laplace of f of t. Okay, but what also is the Laplace of f of t? What is that exactly? Well, that's just f of s. So this whole thing is just f of s. So let's write that down. So this is just f of t e to the st going from 0 to infinity plus s times f of s. Okay, great. That's one less bound calculations to worry about. So let's go ahead and keep going. Gonna plug in our bounds. So this is like, if I plug in infinity, this is like f of infinity. Be careful, it's not times infinity, it's a function of infinity, as strange as it sounds, but e to the s times infinity minus f of 0 over e to the s times 0 plus s f of times f of s. So yeah, be careful. This is not f times infinity. It's just saying a function of infinity. But what we have here is essentially, a function of infinity over e to the infinity, which is just infinity, minus f of 0 over e to the 0. Okay, well, anything to over infinity goes to 0, right? And then f of 0, we don't really know what that is. E to the 0 is just 1. So what this ends up being is just negative f of 0 plus f s times f of s. So therefore, the inverse Laplace, excuse me, not inverse Laplace, the Laplace of y prime is s times f of s minus f of 0. Or if you prefer to write it as y of 0. But that is our proof. Okay, we could do the same thing with y prime, double prime, y triple prime, etc. But I just want to show you guys exactly why, you know, y prime, the Laplace of that turns into s times f of s minus f of 0. And that f of 0 is going to come from your initial condition in the initial value problem. But we'll check that out in the next video when we go over an example. But thank you for watching, and I'll see you next time. All right, take care.